Hey guys. Here's our video for exponential regressions. Okay, so you remember doing regressions before when we did linear regressions. Okay, you went into stat, first choice edit, and you put a list of values. Okay, so 10, 20, 30, 40, 50, 60, and 70. Then our y values go into L2. Okay. Now, I always recommend that you check your entries into L1 and L2 before you leave the screen, because if you make a typo, you won't know it until you have the wrong answer. And you won't, the calculator doesn't say, hey, I looked at your data and you typed it in wrong. It doesn't know, it only knows what you typed. Okay, so from here, if we want to do a regression, first of all, we also should probably turn on stat diagnostics. Remember, that tells us how good our data, how strong of a correlation that it is. So turn that to on. Then you can hit stat, calculate. Now stop and think. We did linear regressions before, and that's choice 4. But we're not doing linear regressions now. We are doing quadratic regression, or exponential regression, which is choice 0. I'll just keep hitting enter. And this is the screen that you get, which I pulled off and put here. Okay? So here's our data, and this is the screen that we get. So remember, our functions are in the form f of x, or y equals a times b to the x. Okay, so they tell us the a, they tell us the b. Now, they give us big, long decimals. Your homework assignment is going to tell you specifically what to round to. For this particular problem, I'm just going to make it up. Let's round to the nearest hundredth. So that means 2 decimal places. Okay. 1.87, this 7 tells that 7, go up to an 8. So 1.88 times our b is 1.06 to the x power. Okay. This r, now we've been talking a lot about r in class, r being a percentage or of a rate. This is not the same r, guys. This is not your rate. This r, remember, there's only 26 letters in the alphabet, and there's like hundreds of mathematical concepts. So, letters have to be able to represent different things in different contexts. This r, remember, represents the correlation coefficient, and it just wants you to look at it and say, oh, gee, how close to 1 is this number, or -1 if it were negative. And 0.979, gosh, that's very close to 1. So that would mean that this data follows an exponential model very closely. It's very exponential data. All right, one extra thing that I'm going to have you guys do on your homework, besides whatever the directions tell you, is also to find the r, because that's an extremely commonly missed thing on your quizzes. So remember, b is 1 plus or minus the rate. So if I know b is 1.06, that's 1 plus r. A lot of you subtract the 1 off in your head. That's 0.06. So that's 6%. Okay, that's an extra step that I want you to do on your assignment. that just to practice. Okay, so let's do some of these homework ones. Now, for the sake of time, I'm going to tell you that I'm not going to go through all the steps for putting in the data and doing the regression. Reason being is, guys, I gave you this handout that tells you screen by screen what to do. So that's up to you. Okay, I'm going to help you interpret and check. This is the screen. Once you put this data in, this is the screen you should get on your calculator for the regression for number 1. So that means that my regression, now I have to pay attention to directions. Those of you that are skimmers are going to miss out. It says write an exponential regression equation rounding all values to the nearest thousandth. Thousandth means 3 decimal places. So if I'm looking at this, I'm cutting myself off at 3 decimal places for rounding purposes. Okay, so that would make this f of x equals 180.37, let's see, 8 tells 6, go up to a 7, times 0.95, 8 tells the 3 to go up to a 4, to the x power. Okay, so that's what the directions tell you to do for this problem. But again, I'm going to stress to you, I want you to do more. I want you to say, okay, the b is 0.954. That's 1 minus r. How come it's a minus this time? It's a minus because it's a decay function. So that means we're subtracting. Now, these are tougher because you get lulled. The growth ones are easier because you're just kind of pulling the decimal out, subtracting off 1 on each side. Most of you do that in your head. These are not, this is decay. It's not that simple. I'm not going to move this decimal point over, and there you go. I have my answer. It's not how this works. Okay, what I'm actually going to do is have these two switch places. R equals 1 minus 0.954, which is 0.046. Make that into a percent, 4.6%. Okay, so that's extra that I wanted you to do. Number 2, pretty similar. Just check that you have this same screen. But you can pause this, get this problem done. Look and make sure that you have this same screen right here. Okay, I'll blow it up a little bit so you can see it. Okay, make sure that you have that screen and it matches, and otherwise it's the same as number 1. Number 3 is a little bit different, because in number 3, you have some extra directions, okay? It says, you know, all the stuff in the beginning, blah, blah, blah. But then down here at the bottom, very important, and a lot of times with years, you're going to want to look for this. Using x equals 1 to represent 1986. Guys, most of the time, however the data is given to us, whatever numbers we see, we use. We do not change data numbers. However, things like days of the week, Monday, Wednesday, Tuesday, those are words. They're not numbers. Okay? January, February, March, those are, again, words, not numbers. It's easy to see that we need to put in some numbers for things that are words. However, years are also numbers. But we treat them like words because we're not tracing every single bit of data we do back to year 0 in biblical times. Okay, that doesn't make any sense. So when we are doing regressions with years, especially if the directions specifically tell you where to start. Okay, the default that Carnegie seems to use is with years start with 0. But this direction specifically said use x equals 1. So in my L1, I'm actually going to put 1 for 1986, 2, 3, 4, 5, and so on. Okay? So that's the difference on number 3. And then number 4, starts asking you to do more things besides the linear or the exponential regression equation. Okay, it wants you in this problem to do the regression equation. Okay, f of x equals, what are we rounding to? Nearest 10,000th. So that's 4 decimal places. That's annoying. Okay, 27.2025 times 1.1509 to the x power. So there's my regression equation. Okay, now pause, because I also want you to find r. So if my b is 1.1509, this is a growth function, so it's plus. Many of you subtract off the 1 in your head. And then move the decimal over. That's my r. Okay? So that was the extra thing I wanted you to do. Now we're going to go back to our regularly scheduled problem over here, because it also wants you, that's part 1 is find the equation. Part 1A is find the rate. Part 2, using this equation, predict the number of single-celled organisms to the nearest whole number at the end of the 18th hour. So f of 18 equals 27.2025 times 1.1509 to the 18th power. And we got to just load that up into the calculator. We get a crazy decimal, but we're talking about organisms. They have to be to the nearest whole, so 341. Okay, 341. Okay, that's your homework. Some of the problems ask you to do more things like graphing and so forth. Have a good day. See you next time.